Okay, so today we're talking about some other types of angles that are formed within the circle. We talked last week about the central angle, and we're going to compare that to what we're going to learn today here in just a second. But today we're talking about the inscribed angle. And the inscribed angle is an angle that has its vertex on the circle and sides contained in the chords of the circle. Okay, this right here is an inscribed angle. Its vertex lies on the circle, and the sides of the angles are chords of the circle. So this right here is an inscribed angle. Now this inscribed angle creates an arc within the circle. Okay, and that is called an intercepted arc. That's an arc created by the endpoints of the inscribed angle and lies in the interior of the inscribed angle. So this is an inscribed angle and has its vertex on the circle, and this is its inscribed arc. And I've given a couple of different examples of inscribed angles here. This one of the chords is actually the diameter, okay, but it's still considered an inscribed angle. This is the inscribed angle, and this right here is the intercepted arc. Now, this leads us to our first theorem for this section, and it's called the inscribed angles theorem. And the inscribed angles theorem states that if an angle is inscribed in a circle, then the measure of the angle equals half the measure of its intercepted arc. Let's say that this intercepted arc here is 60 degrees. Okay, well this theorem says that the inscribed angle is half of that, which is 30 degrees. Now, you remember from the last couple of sections, we talked about a central angle, okay? And a central angle has what relationship with its arc? It's what? Sorry. It's what? I heard somebody say something. What'd you say, Mo? You don't know. A central angle, what's its relationship with the arc? They're congruent, right? Okay. Okay, so the central angle is equal to the arc, but the inscribed angle is half the arc. And you need to know the difference between those two, okay? Because you're going to have to, go back and forth between, okay, if it's a central angle, it's equal to the arc. If it's an inscribed angle, it's half the arc. All right, so a couple of examples here. It wants us to find each measure. So we want to find the measure of angle P. What would the measure of angle P be? It's going to be half of that, half of 70. Here's my inscribed angle, and it's going to be half that, which is 35. Okay. What about this arc here? Here's an inscribed angle. I want to know what that arc PQ is. Okay, the angle is half the arc, so you've got to double the angle. So it's going to be 112 degrees. So angle P is 35 degrees, and the arc is 112 degrees. So remember, the inscribed angle is half the arc. The arc is twice the inscribed angle. Okay, so another theorem says that if two inscribed angles of a circle or congruent circles intercept congruent arcs or the same arc, then the angles are congruent. Kind of a wordy theorem, but the idea is pretty easy. Here we have an inscribed angle, and we have another one. They both intercept the same arc, okay? So if you have two inscribed angles that intercept the same arc, then this theorem says that those two angles are going to be congruent to each other, which makes sense. If this arc, let's say, was, 100, then they're both intercepting a 100-degree arc, so they're both going to have to both be 50, right? Okay. Now, it works basically the same if you have two separate angles that intersect congruent arcs. If these two arcs here are congruent, this angle here intercepts arc FE, and this angle here intercepts arc CD. If FE and CD are equal, then what's going to be true about angle A and angle B? They're going to be equal as well. Okay? So this works within the same circle or If you had a pair of congruent circles and you had one angle in one circle and one angle in another, it would work the same way. Okay, so here is an example. In circle O, the measure of arc AB is 140. The measure of arc BC is 100. And it says the measure of arc AD is equal to the measure of arc DC. Find the measure of the numbered angles. So we want the measure of angle 1, the measure of angle 2, the measure of angle 3, the measure of angle 4, and the measure of angle 5. Okay, so what might we want to find first here? AD and CD, right? Okay, and we know that they're equal, right? So what will we do to go about doing it? Okay, so let both of them be x. So we have 140 plus 100 plus 2x equals what? 360. So that gives me 240 plus 2x equals 360. Subtract 240 from both sides. Divide both sides by 2. And both of these are 60, right? Both of those are 60. All right, so now we have all the arcs. Now we want to find the numbered angles. So what about angle 1? 30. And sometimes if there's a bunch of gibberish, a bunch of lines drawn, it might be helpful to highlight the angle, okay, and see what it intercepts, and we know that it's going to be half of it. Okay, so angle 1 is 30 degrees. What about angle 2? It's also going to be 30. How about angle 3? Okay, it's going to be half of the 100, which is 50. What about angle 4? 70. This is one where there's lots of lines going on. It might be helpful to highlight it and the arc it intercepts. So it's going to be 70. And then what about angle 5? It intercepts the 100, so it's going to be 50. Okay. All right, any questions on what we did there? All right, now here's another one. This one's kind of some common sense, but you got to just kind of think about it. It says an inscribed angle in a triangle intercepts a diameter or semicircle if and only if the angle is a right angle. Basically, what's happening here is that we have this angle that's intercepting the diameter or the semicircle. What does the semicircle measure? It measures 180, right? And so it says that if you have the angle that intercepts the diameter of the semicircle, that angle is going to be a right angle because 90 degrees is half of 180, okay? So anytime you have a triangle and, one side of it is the diameter, okay, and it's inscribed in the circle, then it's going to be a right triangle, okay? All right, so triangle ABD and triangle ADE are inscribed in circle F with arc AB, congruent to BD. Find the measure of each numbered angle if the measure of angle 1 is 12x minus 8 and the measure of angle 2 is 3x plus 8. Okay, so the first thing it tells us is that these two triangles are inscribed in the circle, right? And what do we know? What do we know about both of those triangles? What kind of triangles are those? They're right triangles because they both intercept the diameter of the semicircle, right? And so this angle E is going to be right, and this angle B is going to be right. Okay? All right. Now, with that said, looking at angle AED, what do we know about angle 1 and angle 2? What relationship do they have? They're complementary, right? Because this is a right triangle, this is 90, so there's 90 degrees left for angles 1 and 2. So, I'm going to add them together. 12x minus 8 plus 3x plus 8 equals 90. And so I end up with 15x, my 8's cancel, equals 90. Divide both sides by 15. And so x is going to be 6. And so now we can go and find the measure of angle 1. And that would be, what, 12 times 6 minus 8. 12 times 6 is 72 minus 8, which means the measure of angle 1 is what? 64. Good. So the measure of angle 1 is 64. What about the measure of angle 2? What could I do to find it? They're complementary. You could plug it in, but what relationship do we say they had?
90 to subtract 6.
Subtract 64 from 90, which is going to make it 26 degrees, right? Okay, because they were complementary. You could plug the 6 in and do 6 times 3 plus 8, and that gives the answer as well. All right. Okay, so that takes care of angles 1 and 2. Now we need to go to angle 3 and 4. What do we know about angles 3 and 4? They're what? How do you know they're congruent? Okay, the arcs are congruent. They both intercept a pair of congruent arcs, don't they? Okay, and so since they both intercept a pair of congruent arcs, right here and right here, those two angles are congruent to each other. So, what does that mean that they are? What is angle 3 and angle 4?
Find one equal on the other.
45. So the measure of angle 3 equals the measure of angle 4, and they're both going to be 45 degrees. Okay, because it's going to be an isosceles right triangle. Another thing that you could have looked at here is that because these two arcs are congruent, what's true about the chords? Those are congruent, right? Which makes this an isosceles right triangle, which means angle 3 and angle 4 are equal to each other. So that's another thing that you could have done also. All right. Okay, put a little star by this theorem here. It's a really easy theorem, but people forget about it all the time. It says, if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. Okay? So, remember what it means to be inscribed. If you have a quadrilateral inscribed in a circle, each one of its vertices lies on the circle. Okay? And this theorem says that if that happens, then the opposite angles are supplementary. So that means that the measure of angle B plus the measure of angle D is going to equal 180. And likewise, the measure of angle A plus the measure of angle C is also going to equal 180. So let's look at this example. Quadrilateral ABCD is inscribed in circle P. If the measure of angle B is 80 and the measure of angle C is 40, I want to find angle A and angle D. Well, let's look at angle D first. What's angle D going to be? It's going to be 100, right? Because it's opposite angle B, and that ABCD is inscribed in the circle. So your opposite angles are going to be supplementary. So the measure of angle D is 100. What's A going to be? What? 140. Now, let's talk about what happens if you forget about that, okay? If you forget about that, let's just take one of them, for example. Okay, like I said, this is a super easy theorem, but people forget about it. This angle B intercepts this arc, right? Okay, and so if this angle is 80, what does it make this arc? 160, you double it, right? And so if that arc is 160, what is this arc going to be? It's the rest of the circle. What's it going to be? What? 210? About 200. 200. It's going to be 200, okay? And so now this angle intercepts that arc, which means angle D is going to be 100. So, sometimes you can help yourself work around it if you forget it. But, that's a kind of a little workaround there. All right, so real quick, what we talked about in this section today, we learned what an inscribed angle was. Okay, its angle lies on the circle. Its sides are chords of the circle. And the inscribed angle has what relationship to the arc? Don't put your stuff up yet. Okay, the inscribed angle is half the arc. The central angle has what relationship to the arc? It's the same. So the inscribed angle is half the arc. The central angle is equal to the arc. Okay? And we learned that if you have two inscribed angles that intercept the same arc, those two angles are congruent. Or if you have two inscribed angles that intercept congruent arcs, then those angles are congruent. What happens when you have an inscribed angle that intercepts the semicircle? It makes a right angle, right? It creates a right triangle when that happens. Okay? And then If you have a quadrilateral inscribed in the circle, what's true about the opposite angles? They're supplementary. They equal 180. Okay. All right. Any questions? Okay. Your assignments on the board.